All right, guys, we're going to go ahead and talk about graphs, types of graphs, as well as how to construct your own graphs. So we'll start with data. Data is something that we use as scientists all the time. We do scientific investigations or experiments, and we collect data. Data can be qualitative, meaning no numbers, so descriptive things like colors, how they smell, basically anything like that would be a qualitative observation. Quantitative observations are things that we can describe in numbers, so measurements, essentially. And we tend to organize our data, especially quantitative data, into data tables. We know that graphs are typically a way to visually see something that is in numbers typically. Numbers aren't as easy and fun to interpret, but graphs allow us to interpret those numbers easier. It allows us to compare multiple variables, as it says here, and see the relationship between those variables. They tend to be created from data tables, and there are many different types. So here are all the graphs, the types of graphs. The ones with the X's through are the ones that are typically only in math, not as much in science. So the 5 most common types of graphs are line graphs, bar graphs, histograms, circle graphs, and scatter plots. Circle graphs are sometimes known as pie charts, so you may have heard it referred to as that. In this class, we are mostly going to use line graphs, bar graphs, and scatter plots. So bar graphs. Bar graphs are, especially the single, so that means just one variable, are used to compare qualitative data, so some sort of category, people, place, things, months, stuff like that, and quantitative data, so numbers of some kind, some sort of measurement. So an example would be months, which would be a category, and average high temperatures, which would be a measurement. So qualitative data and quantitative data. This is an example of a table that we would use a bar graph for. You notice that there's a category here, some sort of purple or person, place, or thing here, and then we have a measurement or a count of some kind for each category. This would be a bar graph, okay? That would be an example of a bar graph. A multiple bar graph, so a graph that has multiple bars on it, would be used to compare qualitative, people, place, or things, and quantitative data, just like the other one, except that it shows changes in more than one group. So these have to have keys because your bars are going to be different colors for different groups. So again, our example is months, so that's our category, and average high temperatures, that's one measurement, and average low temperatures, that's another measurement. So we would have 2 sets of bars on this, so we would need a key. Over here, here's our categories, here's our one group of measurements, and here's our another group of measurements. So a double bar graph would look something like this, where one graph is shown, one bar is shown in one color, and another bar is shown in another color, and there's a key off to the side that kind of show what they each represent. The line graph. Okay, this is one we will use a lot in here. It's used to illustrate change over time, and it typically is always quantitative data, only quantitative data. The data displayed by points is connected into lines. So here's an example of a data table that we might change into a line graph because it shows numbers, quantitative data, or time, and a measurement of some kind. So in this case, number of leaves. Okay, and that is also a number. So quantitative and quantitative data. Okay, and we would connect the lines when we're talking about growth over time. A multiple line graph is used to compare 2 groups of related data over time. So data is displayed by connected into 2 lines and typically uses all quantitative data. We need a key here because each measurement, each group of measurements will need their own color or their own line. So here we have the time, and then we have these guys right here, which would be their own color in the graph, and then these guys right here, which would be their own color in the graph. Oops, sorry, let you look at that for a sec. So that's the, I don't think I can scoot over anymore. We'll try that. All right, just so you can read what it says. Okay, and now this is our regular line graph, so single line graph. You'll notice that we have days or a timeline and then some sort of measurement. And this would be our multiple line graph. Again, time and measurement. Circle graphs, or pie charts, are used to display parts of the data in relation to the entire amount of data, or percentages. Whenever we have a percentage, we use a pie chart or a circle graph. All circle graphs need a title. All graphs need a title, by the way. Each part is called a sector and is labeled with the percentage. So when you calculate the percentage, it's labeled with it. And then a key is always included. Remember that you have to create correct angles, and you can do this with a protractor, right? Because there are 360 degrees in a circle, and you're going to have to measure what percent of the circle would be each thing, and then use your protractor to create the correct angles. So this is an example here. Okay, don't forget we have our key here, we have our title, we have all that important information. So scatter plot. This shows how closely two sets of data are related. So this is what happens when your data does not happen over time. So the closer related the sets of data are, the closer the points come to forming a straight line. And we can look at that when we draw a best fit line. Scatter plots typically include, like I said, best fit lines, which shows a line that goes directly through the data showing the trend. This would be a scatter plot. Does not have a best fit line, but you'll notice that kind of points are kind of everywhere. If we were to draw a best fit line, we might draw it right through here, and we could look at the trend that as the study hours increase, the grade increases. So when to use each type of graph. So the line graph. So when I'm wanting to use a line graph, I understand that I'm looking at changes over time. So if the x-axis or the independent variable is some sort of time, then I would use a line graph. And it's going to, like I said, show the relationship between two quantitative things. And the single one only for one population. Sorry. A multiple line graph tracks changes over time as well, both short and long periods, and shows relationships again between two quantitative things. It shows changes in more than one group over time. Now remember, I don't have slides for these, but the circle graph or the pie chart is used when we want to show a percentage of a population, and a scatter plot is when we want to show two quantitative relationships, but one of them is not time in any way. And then bar graphs are categories and measurements, okay, or qualitative and quantitative data. So how to make a graph. You guys should all remember ICATS. The I means your intervals. When you're creating a graph, your intervals should be evenly spaced. That means if you're going to count by 2s, every single line equals 2. If you're going to count by 5s, every line equals 5. Okay? Each axis should have its own interval system, and that's what you have to stick with. If it's a grid that I've already given you, okay, making sure that the grid lines make sense, meaning you're using a decent amount of it. And don't plot 0. If it doesn't have it on there, don't plot it. Color. Guys, if we do graphs in class, use color, especially if you have more than one category. And if you have more than one category, then you need a key. Making sure that you have all of those things in a graph is so important. Axes. You should be labeling both of your axes using the appropriate units as well. So that means that if it's measured in grams, it should say grams. If it's measured in degrees Fahrenheit, it should say degrees Fahrenheit. If it's measured in meters, it should say meters. Also making sure that the independent variable or cause in your experiment is on the x-axis with the units it's measured in. And the dependent variable or the effect is on the y-axis along with the units it's measured in. T stands for title. So this is naming a graph that includes the variables from the x and y axes. So it might be whatever your x-axis is versus whatever your y-axis is, or it might say the effect of whatever is on your x-axis on whatever's on your y-axis. It needs to be underlined and it needs to be placed in the top center of your graph. S means space or size. This should use the majority of your graphing space. So if I give you a huge piece of graph paper, you need to be taking up 75% of it with your graph. None of these little tiny graph things. Okay, I don't know what those are, but I don't like them, and you shouldn't be using them. graph only the required data. So if I only want you to graph the averages, I don't want to see all of the trials that you did as well, just the averages. Okay, so make sure you have graphed all the required data. And if it is over time, make sure you've connected them with a line. If it is a scatter plot, make sure you've drawn a best fit line. We'll practice doing those this year. So yeah, that's your review on types of graphs as well as graphing. So get ready to do some amazing graphing tomorrow in class. Thanks.